Hi everyone, I am Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today I am going to talk about solving problems of spherical mirrors. First thing we need to know is the sign convention. Okay. Now conventionally the object, here it is AB, that is always kept in the left side of the mirror, that is in front of the mirror. Okay. The rays are emitted from the object, therefore the rays are shown from left to right, that is the direction of incident light. Any measurement is done with respect to the pole of the mirror. So if you are doing the measurement in the right side of the pole of the mirror, that will be positive. If you are doing any measurement in the left side from the pole of the mirror, that will be negative. Likewise, if you are doing any measurement from the principal axis above it, then it is taken positive. Any measurement which you are doing below the principal axis is taken as negative. So this sign convention we need to be very clear about, and we need to apply this sign convention when we are doing the measurement and marking the position of object or position of image or even the focal length. Okay. Let's take this example. Complete the following ray diagram of the concave mirror. Okay. There is a concave mirror given and there is an object which is placed between the pole and the focus. Okay. Now you might have read in your ray diagram, now I am drawing it for you, is that one ray has to go to the parallel of the principal axis and it hits the mirror and will get reflected and it will cross through the focus of the mirror. And another ray has to pass through the center of the mirror. Now, if you see this side, the gap between these two are constantly increasing, so they will never meet in the left side of the mirror. So what you need to do, you need to extend it in the right side of the mirror. So this dotted line is showing the first ray which it got reflected towards the focus. You show it with the dotted line in behind the mirror. Likewise, the second ray which is reflected from the center, that ray is again extended and then these two rays are meeting here. So therefore the object formation will be happening here. Now because it is happening behind the mirror, it will be virtual, right? And in your ray diagram also you might have studied that if the object is placed in between the pole and the focus, then the virtual image will be formed in case of concave mirror behind the mirror. Okay. Now let's try solving the problem related with that. And the problem is that find the position, magnification and the nature of the image formed when the focal length of this mirror is given 30 centimeter and the object is placed 15 centimeter in front of the mirror and this 15 centimeter has been measured from the pole. Okay. Now let's try solving that. But before solving that, we will be using mirror formula. Mirror formula is 1 by V plus 1 by U is equal to 1 by F. V is the distance of the image formed from the pole. U is the distance of the object from the pole and F is the focal length. Okay. Now this is a case of concave mirror. So if it is a concave mirror, the focal length will be negative. And why it will be negative? Let's look at quickly. If suppose this is a concave mirror, okay, and you are sending parallel rays to the concave mirror, then these rays will get reflected and they will hit the focus. Okay. Likewise, this will be hitting the focus, and this will be the direction of the reflected ray. So this distance, if it is pole, then this distance is the focal length f. Now you can notice that to measure the distance of the focal length, you have to go left of the pole. Therefore, for concave mirror, the focus will be negative. Okay. Likewise, if you are putting the object anywhere in the left side, in this case the object has been put between pole and focus, in this case also the u will be negative. Okay. Right. So let's now put the values. I will rub it out. Let's put the values. So what do we get? The focal length, because it is a concave mirror, I explained that in case of concave mirror, the focal length will be negative, that is minus 15 centimeter. The object distance u will be equal to minus, okay, there is a bit of error here. The focal length is not minus 15, rather the focal length is minus 30 centimeter in this particular case, minus 30 centimeter. Okay. And the object position, which is here from the pole, is 15 centimeter again in the left side. Right. So this is the value and the corresponding sign of u and f. Now we have to find out that what will be the value of the image distance from the pole. So we will use mirror formula, which is 1 by v plus 1 by u is equal to 1 by f. Therefore, we will write 1 by v is equal to 1 by f minus 1 by u. And we will put the values along with the sign. So this is 1 by f. F is minus 30 minus 1 by u, and u is minus 15. So then we will get minus 1 by 30 plus 1 by 15. So here we will get minus 1 and plus 2, and therefore this becomes plus 1 by 30. So, but be careful, that is, it is 1 by v, not v itself. So therefore, v will be equal to plus 30 centimeter. What this plus 30 indicates? That the image should be formed on the right side of the mirror measuring from the pole, which we see from the ray diagram also, that the image is getting formed in the right side because the value of v is plus 30. So it means it is getting formed in the right side. Okay. Now, what is the magnification? The magnification of this, using the magnification formula, is height of the image divided by height of the object, which should be equal to minus v upon u. Now we have not been given h dash and h, but we have been able to find out v and we were given u. So we can use this as magnification is equal to minus v upon u, which will be equal to minus of plus 30 divided by minus of 15. So this becomes then, this is plus plus and then 15 2s are, so this can be written as plus 2. Now magnification is plus 2, it means the image is erect and therefore image should be virtual, which we also see in this case, that image is virtual and it is erect, and the image has been magnified 2 times of the original image, original object. If height is given, suppose height is given as maybe 3 centimeters, then the magnification h dash of the image will be, the size of the image will be 2 times 3, that is 6 centimeter. So by using the right sign convention and putting the right signs in the measurements, you can find exactly that what should be the position of the image, what will be the nature of image, what will be the magnification of the image, and you can solve any problem related with spherical mirrors. The convention is same for both concave and convex mirror. I would rather further extend it that the same convention is used when you are solving the problems of spherical lenses also. Okay. So with this, I am hoping that you will be having the confidence now to solve any problem related with the spherical mirror. Thank you.